Before we get started, my name's Rosemary and Alan is kind of co-host with me. The next seminar, the one in February, is going to be February 28th at 11 a.m. Pacific again, 2 p.m. Eastern and 1900 Universal Time. April Witt is going to give a seminar called How Can We Keep Them Engaged When They're 8 meters away? So something different from today, more on an interactive planetarium show. Today's speakers, we have Micah Achinapura and Alex Bach, right, and Megan Villa, all from OpenSpace. Micah is a software engineer and is at the American Museum of Natural History. Alex leads the development team at I should have asked this, Linköping, is that right?
Close enough.
Close enough, University in Sweden. And Megan is the project coordinator at the American Museum of Natural History. So with that, if there's no questions, I'm going to ask everybody who hasn't done so already if they could sign in to the chat. Just put your name and where you're from. And I think I'll turn it over to OpenSpace.
All right. Okay, so I'll start with a little bit of an introduction to get everyone up to speed. And then I'll hand over to Micah, who's going to be spending the majority of our time together to do some demonstration on what you can do with OpenSpace and also doing it a bit Q&A-like to see like what we can do to answer everyone's questions, but also at the same time make everyone who's watching the video later but satisfied in this case. So yeah, thanks for the introduction. Alex Bach, my name, Linköping University and the Norrköping Visualization Center, and here as the lead developer for OpenSpace. So first of all, I guess the first question is, if people haven't heard about it before, what is OpenSpace? Usually I like to explain it to people as a game engine without all of the gameplay elements. So basically, instead of collecting points when jumping through hoops, instead we throw real data at the computer and can render it as realistically as we can make it onto a large number of different display devices. And basically, for our foundation, and we're going to see a bit later as well, we have these three pillars. So first of all is we want to contextualize scientific data. The reason for that is that we want to enable scientists to bring their science into the planetarium or into another display environment to talk to the general public and get everyone interested in continuing with STEM education. From my point of view, I also am assistant professor in visualization. I want to do visualization research, which OpenSpace has its origin, and we're continuing to do that as well, which is not that interesting for this group, but just knowing that there is research under the hood that makes all of this possible. And then lastly, we want to reach out with OpenSpace into domain-specific research. So we want to talk to astronomers, want to talk to microbiologists and enable them to use OpenSpace in their daily work for their actual research, because then we're able to bridge this gap between lab and the dome. For this, we have the ability to render on a large number of different display devices, going from laptops, normal PCs, power walls, caves, fixed dome theaters, mobile dome planetariums, and many, many more, where we're trying to do some novel interaction techniques in order to enable both the presenter, but also potentially the public to interact with the software in real time to facilitate live and interactive presentations. And as it's probably implied in the name, OpenSpace, the open part, it's all open source. So the entire software is out on GitHub. It's free, it's under MIT license, so anyone can use it without any licensing fees and for more or less whatever purpose. Which is extremely broad, and I think that's one of the attracting factor for looking into the software as well, because well, it's free to try out. What's there to lose? So the idea behind OpenSpace all started with this idea of this confluence of software that was going on between exploration and explanation. Exploration in this case means a scientist looks at a data set potentially for the very first time, has not really a good idea what's contained in the data set and wants to explore it to find out yeah, what is in there? What kind of science can I tease out of this? Converse that with the explanation phase, where we have a piece of software, we throw a data set at it, we know what's in that data set already. We just want to present it to a lay person who wants to get something out of this. So the idea behind this is like, why don't we just do both in one software? And my PhD advisor coined this term exploration for this, smushing those two words together, which I know you're not really supposed to do in English, but well, we're not native speakers, so we were doing that anyway. And this leads to like a set of my two favorite pictures in the world. I've shown them for a few years now, and I haven't found any betters yet. So these ones are from about 2017 or 2018. The picture on the left is in Brooklyn, where NYU, where I was at the time. They asked us to go out and do something interesting for the public, basically to show the general public what NYU was currently working on. So we got a laptop and a screen, and then this boy came, multiple people came along, but in this case, this boy is holding a game controller and is flying over Mars and exploring that planet for the very first time. A bit later, maybe a month later, a week later, or something like that, we had Jack Mustard from the Perseverance science definition team in town, and he is lying there down on the right, down on the ground in the Hayden Planetarium, also looking at Mars, but with a different data set. So he's looking at the CRISM data set that gives us chemical composition of Mars. So exactly the same software, mostly the same data actually, but two very, very different viewpoints onto the software. And like this is what I was talking about with this confluence of both at the same time. Here's the mandatory support slide. We're very grateful for long-running support that we've gotten from NASA for almost 10 years at this point. And then on the Swedish side, we also have support from the Knut and Alice Wallenberg Foundation. So when it comes to the development, the whole project was started by my university, Linköping University, together with the American Museum of Natural History. And these two entities have been driving the development of the software forward for almost 14 years at this point. So it's been a very long collaboration between our two institutions, which has been extremely fruitful. With the as we got the grant, the NASA grant in the US, we were able to bring on the Scientific Computing and Imaging Institute from the University of Utah, and Tendon School of Engineering from New York University as well, together with the Community Coordinated Modeling Center out of NASA Goddard, which has been also a partner for many, many years. It is truly an international team that we're working on it, with about 50-50 split between Sweden and the US. So we have all of the different developers that are working on the software on a daily basis that are distributed. I was going to say all over the world, but more like one hemisphere of the world. And the other thing that is really interesting and very important to know, I think, for potential users of OpenSpace is this row at the bottom, these 4 rows of people. Those are all master thesis students that have gone through our program and have done their final year 20-week project within OpenSpace. So they are the ones that try out new things, experiment, implement new features that then the software developments later go and harden and actually bring to fruition in order to bring it to the general public. So this has been going on also for many years, and we can also see that the timeline progression of gender distribution has also swung heavily in towards 50%, which is fantastic. All right. I wanted to just show this webpage because it kind of shows the reach that OpenSpace has had over the last 5-6 years that we've collected this data. And I'm on fairly unstable internet, so let's see if all of this works. So when you go back to the video, you're going to see the URL, so anyone can just go to that and go to the webpage. But I think the Google gods are not with us, so I think I need to leave this as a teaser. What you can imagine in your mind's eye is a map of Earth with pins all over the place. Because as of the years that we've collected this data, people have been downloading OpenSpace all over the place and been using it, experimenting it, maybe just starting it up and shutting it down again, maybe giving 5-hour-long presentations about the world to their neighbors. And this reach has been truly, truly fascinating. what this is. And of course, now it was starting. All right. Yeah. So there's been a lot of users that have been going to use or that are using OpenSpace. Another thing that I want to highlight here is that there's a community that is being built as well. So if you are one of those users or potential users, on our webpage, openspaceproject.com, there's a link to our Slack channel that you're all very welcome to join and ask questions. And there are other people that can answer. We from the development team are there to help answer questions as well, and people to be able to share created content with each other and build a community around this software. So as Micah is going to show, there's a lot of different data sets that we can present in OpenSpace. The first one that we did was the New Horizons flyby, now almost 10 years ago, where we connected a number of a dozen or so planetariums around the world to witness the flyby at Pluto at the same time, but also slightly more modern missions like Rosetta, or slightly more older missions like in this case Apollo 8. But there's a whole swath of different missions that we have made, but also more importantly, we have created the tools for users to tell their own stories fairly easily as well. So I was talking about the 3 pillars. This video is a simulation that the CCMC out of NASA Goddard has made. The video that we're actually watching is a live stream that Leila Mace, the deputy director of CCMC, was doing online during the pandemic times. So what we're seeing here is a volumetric simulation of the plasma as blown out from the sun during a coronal mass ejection, and concluding with all of the tracer particles and field lines and so forth. So this is a fairly complicated story that is being told here by Leila. It is included with OpenSpace, so this is one of the great examples where we have a ready-made story that is already on YouTube that anyone can just pick up and tell in their own planetarium. And down at the bottom, Emily and Christian were the 2 master students that implemented this at Goddard. But of course, also more for traditional outreach. So here's some image from the B612 Foundation. They're tracking asteroids and see which ones could potentially hit Earth. They've been using OpenSpace for a number of years for their outreach material, where they put their information about asteroid trajectories into the software and then are able to render them. But also we are working very heavily on a research project together with them to better visualize uncertainty of asteroid orbits as well. Here's a background image for a video for a TED talk that Juna Kollmeyer, the head of the Sloan Digital Sky Survey, was giving. That she needed a video for her TED talk of her data for, which we very happily provided, of course. Some more data from the DAISY, from the dark energy spec instrument. This is the early data release, but still the data is all available. So this is one of the data sets that we didn't make, but rather a user was making. So this is showing again the flexibility of the software to basically pick and plug data from wherever you need it. Moving back to traditional planetariums, here we have Jackie Faraday standing in the Hayden Planetarium in New York, looking at the Gaia DR2 stars. So these ones are on the order of 1 billion stars that are being rendered in OpenSpace in real time. So able to fly around and look at moving star clusters. And in this case, she's presenting to, I think, the Gaia DPAC team that is pretty high up in the Gaia consortium. But all of those things that I've shown so far, they're mostly targeted towards planetarium, naturally, given where we currently are and what we're talking about. But I would be remiss to not highlight that it's also possible to do quite a few other things with OpenSpace as well. So in this case here, we have an example from my science center where we're using OpenSpace in a holographic display to allow people to fly to different planets. So you see the touch screen on the left where a visitor can choose a planet and a moon. And then because it's all interactive, the software will fly there and then show them that it's there and what the distances are and so forth. Including also more elaborate exhibition pieces that have a lot more explanation to them. So the Apollo missions on the right or the Quasar and SDSS data sets on the left, for example, with additional information and touch screens and so forth. So all of these things are mostly built into the software already. Of course, you would have to bring your own story in this case, but I mean, that's what everyone is really good at as well. And then lastly, as an example, here's what they call the WOW room at NASA Goddard, which is a three projector a three projector curved screen that they're projecting into, that they're using to show their simulations that they're doing in OpenSpace to visitors of NASA Goddard. All right. Right. I don't know why. Oops, I mixed up the slides. Before we go to the demo, sorry for the tease, I wanted to just highlight that apart from the meeting here, we do have monthly community meetups that Micah is leading, which are happening every second Monday of the month. If you join the Slack, there's a Zoom link that gets distributed where you can ask questions, or not only Micah's presenting, but in this case, for example, last month we had James Hedberg from the community college, no, the City College in New York, that was presenting about how he's making his extremely viral Instagram videos using OpenSpace. So not only for interactive presentations, but also for pre-rendered. But then normally it looks a bit more like this, where in this case, we're looking at how someone could add the Parker Solar Probe into OpenSpace. This was a month before the closest approach, so it was very timely in this case as well. And then finally, we're also going to have a user meeting at the American Museum of Natural History from July 31st to August 1st this year as well. So this is the first time that we're actually getting people together physically in one place and being able to talk about everything OpenSpace, ask questions, share information, share best practices, and this is going to be really, really cool. So I'm extremely looking forward to this summer. And now I'm going a few slides back. So I'm handing the reins over to Micah, who's going to be showing you the software.
All right, awesome. Thank you very much, Alex. So hopefully from that, you guys kind of got a overview of the whole scope of our project. It's, our planetarium software and then some. And now we thought we'd first show a little bit of a demo of our kind of, grand tour and showing the just a broad scope of everything, and then maybe go into giving a few examples of adding some data and layers to some of our planets. But I would certainly say if anyone has some questions, feel free to ask them. You can put them in the chat. You can unmute your microphone. If they're about something that I'm showing right now on the screen, feel free to just unmute and ask, or we'll also have time for questions later at the end. But we'd like it to really to serve you. So if you have, please feel free to get in and don't worry about me. Okay, that being said, let me see if I can share here. And nope. Oh, okay. There we go. Okay. So hopefully you all are looking at Earth. We generally like to start our presentations at Earth, and since this was PPA, I thought I'd start in this region over here. So I'm actually going to take us away from Earth right in the beginning, but we'll come back and look and talk about Earth at the end. All right. Yeah, I thought, hey, probably most of the time everyone's just repping California, so I thought I would give it go a little farther north, All right. So here we go. And I would also say that normally when we were giving a presentation like this, we wouldn't have my mouse on the screen and these menus and stuff and the words, but since you all are planetarium professionals, we thought it would make sense to show it this way so that you can see what I'm doing and following along. And part of the show will also be explaining a bit of what I'm doing, and you can see how it works and see everything that's happening. And so, I'm zooming out from Earth, and you'll notice the clouds have come on, and these are the clouds for for yesterday. If I go to today, one of the questions was about sometimes I go on the Earth and there's no image. Well, guess what? Today's clouds haven't been captured yet. They have been for this part of the world, but not for that part of the world. So you might often see that. So let's just go back. So as we zoom out, I can even just press my S key and turn on our satellites here. So now we're looking at the satellites that are orbiting Earth. And these are downloaded every day from the Celestrak website. And, they can be nice to talk about, how this satellite imagery and data around Earth is captured. We can also increase time. I'm just using my arrow keys to change time here. And so then we can watch them spin around Earth at their various rates. So now let's just leave Earth and go a little bit farther away. We see Earth's natural satellite coming into play, Moon. And so I could just press L here to turn on my labels and show that's the Moon label. But we'll go out a little farther and we'll take a look at our solar system view. Should be a pretty familiar view to most people. One of the things maybe that's a little different about what we do is how we fade off the trails compared to some other softwares. Not really sure what your software might do with the trails, but hopefully everyone knows what the solar system looks like. And we'll actually come back to the solar system and look at some of the planets on the way back in. But I'll start just by going out, and then here where I'm going out now, all of a sudden our solar system just becomes the sun. And now I'm out here in the Milky Way and the stars turn into our 3D. And now maybe I might start turning on a couple of data sets here. Often when we're at this point, we might show the exoplanet data set that's showing all the exoplanets that we have. So you'll see we have stuff like organized into the hierarchy here. We have solar system, Milky Way, and universe. And then something like exoplanets, we actually have it separated into two categories. One of exoplanet candidates. So we took the data set, and these are ones where they think they're exoplanets, but they're maybe not confirmed. And then we have the second one that is confirmed. And most of our items, if you go here and click this little show object details, you can get a description of the data set and find out what's in it and how many. As we zoom out, well, we also have things like grids. We often might show that one in conjunction with the radiosphere, showing, how far our radio signals have reached from Earth. And so that can be a nice one to show how many potential exoplanet systems might have heard from us. But I'll zoom out a little farther, and we'll go out and take a look at the Milky Way from outside. So now we switch over and we're looking, we have this kind of like volumetric representation of the Milky Way. I leave the radiosphere on here so we can kind of see where we are. But we could also, turn on other types of data sets that are in our digital universe catalog, like different star cluster data sets, globular clusters going off the plane, or maybe H2 regions within the plane. And then we have some different things like maybe the orbit of the sun as it goes around the Milky Way. So once we're leaving the Milky Way, now everything is under the universe, and we're talking about galaxy surveys and different galaxy surveys and data sets. And so here we're zoomed out and we've shown the Tully galaxy survey in the background coming in. But we also have something like nearby surveys for the local group and local groups of galaxies. And so here, now we're at the Tully galaxy survey where we've color-coded them by their density to try to help kind of pull out the web. And this is an example of a couple of these galaxy data sets we will automatically turn on and off for you as you fade, but there is other ones that you can turn on and off yourself so that you can, if you did want to talk about them, you can show. But basically, we will just turn on the Tully one for you, and then also the Sloan Digital Sky Survey. as Alex was showing, which probably a lot of people are familiar with this view and this view of it. And then as we pull out through it, I kind of like to pull through it. Then we see the quasars, and we reach you to the CMB. And so we just wanted to get out to the edge to kind of be able to reach and show the different scales of the data sets. But now I'll come back in and mainly show some stuff in the solar system. If anyone had any questions as I'm coming back in, feel free to ask.
Can you go outside the universe?
Yeah, you can. It's weird. Some people that I show it to are like awesome, and then some people I show it to are like, no, don't go outside. So I never know if I'm supposed to or not. Like when I'm like when I'm showing it to a group, I never know if they'll want me to or not. So here we go. Now we've gone outside. And our visible universe, so to speak. But sometimes I just try to stay within. But yeah, it all depends on if you want to explain it or not.
Philosophical question.
Yeah. But it does give a chance to talk about, the visible universe and what does it mean and how far do we know back and what do we know there. So actually, I was maybe not going to show this, but I think I will, since Alex mentioned that like a lot of the we have these students that come and do their work and explore new stuff and explore new ways to show data and add features. And one of the projects, which is really great and it's awesome, and I use it all the time, I'll probably use it next week when I'm giving a show, was this exoplanet module. So I showed these rings around the exoplanets where we could show like which stars we found exoplanets, but we've also been able to take the exoplanet archive and create this module where you could search for any exoplanet system. I'll just use TRAPPIST since it's the most famous and everyone's familiar with it. I can add it.
Mika, are you showing something at the moment? Because I cannot see the screen.
Yeah, I am.
You might need to select it in the top of Zoom. There's like a meeting, and then next to it, it says Micah Chinapura in the sharing. All the way at the top of the top menu bar in Zoom.
Oh, yeah, sorry about that. Sorry about the interruption. Thank you.
Great. So, actually, and then I do see a question in the chat that says, can you focus on or go to objects outside the solar system? And it's actually perfect that I was going to show this exoplanet because it will give me a chance to explain when you can and when you can't. So here I was going to add the TRAPPIST system. So I had searched TRAPPIST and I hit add system. And it's only now that I added this system that I could actually go to it. Normally, I would not be able to go to a star because we have stars as just one catalog. So the entire star, each individual star is not an item to go visit in OpenSpace, but stars are one item to turn on and off and adjust their properties. But now that I've added this exoplanet system of TRAPPIST, I can click on this and actually go visit it. And so there's a bit of a mixed answer in that in order to focus on items outside of the solar system, you actually have to add them into the scene. And so we have lots of different ways you can do that. Our exoplanet module would be an example. We have bookmarks where you can add bookmarks for places you want to be able to go, or sometimes people might even have a 3D model of an object like the Crab Nebula, could add that in and then go visit that 3D model. And so here we're looking at the TRAPPIST exoplanet system visualization. I won't spend too much on it. I just thought since it was there and it works with the question and Alex had mentioned about the student work, I thought it would be nice. And so, you know, we have settings here like turning on and off the habitable zone, showing a 1 AU comparison. So we cannot say go to Betelgeuse and see what the view looks like from there. So correct, I cannot just like pick Betelgeuse and target it. But if we did know if it had an exoplanet system, we could use the exoplanet module to go to it. Or we could use our bookmarks to go to it, maybe something I can show later, to create it. Or if you just wanted to see what the view looked like from there, I could, you know, turn on the stars. And if if you find it in the night sky, you can just move it in front of you. If I want to see what the view looks like from SCAT, I could just go to it like this. But we make bookmarks to make it easier so you don't have to browse around to it like that. So now I'm going to pick Earth and bring us back to our solar system. And so there is, you know, a lot of different topics that we can show and data sets and different things we could get into. And so one of the things that we thought to show would be some of the different layers that we can add onto the planets. In particular, I was going to show a couple of different things on Earth, and then maybe 1 or 2 things on Moon and Mars. So I'll just turn off my satellites and bring us back in time to get a nice view of the Earth. And so our default view of the Earth, how accurate are the colors for the stars? They should be pretty accurate. Usually we are getting some comments about the size of the stars and their glare and stuff, but I have not gotten too many comments about the colors. I know that there was a decent amount of work done by Carter and then Brian Abbott, our astrophysicist, and one of our developers around the look of the stars. So I would hope there, Alex gives some more information there. So yeah, basically I just was going to show some Earth and also talk a bit about our globes and how they work and the layers. And our default you know, view from Earth is these clouds. And I'll just change time here so we can look. But the thing is that when I open up our menu here and look at Earth, and I look at our layers, this is how we compose our globes with a series of layers, color layers for the way they look and height layers for the forming the globe. You're going to see the one I have turned on is called combo, and that's because as I zoom down, it's actually fading between 2 different, so it's a combination of 2 different layers, a combination of the Esri world imagery and the VIIRS. So our base layer for Earth is the Esri world imagery, which you can think of as similar to Google Maps. As you zoom in, it's just going to get better and better all the way down to where, you know, you can see a school bus and a car and stuff. And so I'll give you just that view that it looks like from there, but now I was going to actually zoom back out and show a bit about some views from space and some overall global layers and stuff. So that layer is the most common and it's just our default layer and it's turned on and available all the time. Now, but there's a lot of other stuff that you can add in, both stuff that we have built into OpenSpace, either available in the files that you can choose which layers you want or don't want. And then we also have these ability for you to add in layers and data and stuff that isn't already built in. And so I just wanted to show and mention a couple of those. And then, you know, depending on the time and what people think, we could even show how to add some of those. But I was going to show a couple different sources, and the first source that I thought to show from was the NOAA Science on a Sphere. So they have their data set catalog, which has a lot of different data sets that are available. And we have taken like their files and included them into OpenSpace to make them available for you so that you could show something like here. I have Science on a Sphere cropland intensity, and I can just turn that on there. And now I'm seeing that cropland intensity. And for some of the layers, depending on how they, what they included or not, it might also include like a legend that they have included, like this slide here. And so in this case, since I decided, oh, for this profile, I'd like to include this layer, I also got the legend going with it. And then sometimes you'll see there's different versions available of the same one with country borders, one without. Sometimes those layers might like take over the whole globe, or sometimes they might just overlay with our existing layers. So in this case, here's like a volcano location. And so you see if I zoom in, our layers are still working, and these are just kind of laid on top. But sometimes they're also going to include like a base layer that goes with that. So in this case, here's their base layer for the volcanoes, and you can choose to use that or not if you want. And so we have a lot of their stuff available like that. But they also have some stuff that is available like as a video from them. And so in this case, we have like a black carbon video that I got from them. And this one is using our like video player layers. And so I actually have like a video wrapped around the Earth. And I can go to my video player and hit play. And in this case, I'm actually, we're seeing the black carbon kind of moving around. Now, maybe I don't want to like mess with the time to see the whole Earth, so I'll actually go and say global illumination. So that way I can see the whole Earth when I'm watching this video. And we have the option to have it loop or not. And so some of the stuff you want a video, some of the stuff is an image with legends, and there's a couple different options. Now, another and I thought like initially I was going to show how to put together that video and add it because it's pretty easy. I think I could show that later at the end if people are interested, but instead I'll show a couple other things and then take some questions. Another source, great source of layers for Earth is this NASA Worldview or NASA GIBS, the Global Imagery Browse Service, and Worldview is a great website for accessing that. They have over 1,000 layers available. I just have a couple added here, so I'll add the sea surface temperature, for example. Here, it's adding the sea surface temperature, and just like I was showing with the volcanoes, the layers may or may not combine with the layers that we have on the globe already. And so in this case, it's actually great because it's this temporal layer means that it will change over time. And since our clouds change over time, the sea surface temperature would change with it. Again, as maybe I showed, I can hit show object details, and then it will give me some information. It says the temporal resolution is different. So what that actually means is if I want to go down here, I can actually change the date, and it will take a second to load, but I can actually change the date and see how the sea surface temperature changed either on a daily, or I could jump it by month and see how it changes monthly if I wanted. And then you could watch it move north and south, the average temperature, etc. Yeah, the question was about the laptop. Is there any tech issues running it on a laptop? I'll just say I'm running it on my laptop right now. I'm giving this presentation off of my laptop. Now, I might happen to have a pretty good laptop, which is why you'll see up in the corner, I'm getting 200 over 200 FPS. And that's because I have a really good laptop, but you wouldn't even need to get 200 FPS. So you wouldn't need to have such a good laptop. But yeah, basically you need a laptop with the NVIDIA graphics card is what it comes down to. And so, yeah, here is the sea surface temperature. And here is, I can see something like a chlorophyll layer, which is going to help me to show about like basically life in the ocean. Not exactly a biology earth observing expert, so I can't really say more about it than that, but it works similar to the sea surface temperature one. Jeff raised his hand. Go ahead, Jeff.
Yeah, Micah, how much is this is being streamed online and how much is baked into OpenSpace offline?
Great question. So basically everything in OpenSpace is offline when you download it, except for the maps of the planets. And so the maps of the planets are the one thing that uses the internet as you're browsing and as you're going. And so everything I showed except for the surface of the Earth. That being said, for something like a mobile planetarium, I know there's someone in there, we do have a caching system where if you browse and visit those places when you're online and you have the cache enabled, and it will save those maps onto your hard drive, and then you could go when you're offline and you'd still be able to visit those places and see all of them. But if you went to a different place, it wouldn't load.
All of this SOS and the worldview stuff, that's all offline, right?
No. So I guess I should add a mix. So the worldview and these temporal daily sea surface temperature and chlorophyll, something like that, that's all loaded from the internet. As I change the day, you don't like watching it load. Something like the science on a sphere is like when we were looking at the volcanoes. That's loaded from the internet the first time you ever use it, and then you never need the internet again. So the thing is, there's so many layers and files available, we don't have people download them all for OpenSpace because you'd wind up with hundreds and hundreds of gigabytes and layers that you never use. So one of the features of OpenSpace is that when you access like a file, a layer, a mission, a 3D model, asteroid, data set that you've never used before, it will download it from our servers. So you need the internet the first time you use it, like if you want to show the New Horizons mission. But then next time you use it, you would not need the internet.
And that's all on the OpenSpace servers. You're not getting your individual laptop is not connecting to NASA, for example. It's connecting to OpenSpace server.
For everything except for this, when I started turning on the ones that were the NASA Gibbs, so like the sea surface temperature, those ones are coming from NASA and our daily weather image.
Oh, great. Thanks.
Yeah, Rosemary.
So I'm just curious about the science on a sphere. This
Yeah.
may be a function more of my planetarium and system, but the movies I've downloaded from there, the resolution hasn't been very good. And so I'm wondering if you take the images, separate images, and make your own video from that.
Yes. So that's exactly correct. So I went to their FTP site, downloaded the images from their FTP, and then just ran one command to turn them into a video. But even so, they still were not quite the resolution I would love. But that is the way to get the fullest and best resolution is you can go on their FTP and get the PNG files, the 2048, and if they had them 4096, that would be like the name of the folder.
Yeah.
And so I actually, that's like how I did it. And then so yeah, like OpenSpace, we could even support a higher resolution video for the Earth if when they are available. But to be honest, this one is not terrible. This one you don't actually need the resolution so much because it's kind of wispy already. So it helps to get the point across.
Thank you.
Yeah. The question was, can you have it installed in the computer and switch between the two with other softwares? And the answer is definitely yes. That's one of the things that's great about OpenSpace is that we do not interfere with other softwares and installations when we're running. Basically, OpenSpace works where in fact, we don't even have an installer that installs weird stuff in hard to find places on your computer. We actually just have a folder. You unzip the folder and everything is just in that folder and you have just that folder and you can move it to other computers. You could run it in conjunction with other stuff. I'll just add a little caveat on the very last sentence where you asked about if switching between the two. Some programs run in full screen and some don't. And so sometimes if you're running two programs at full screen, you have to quit one to start the other. It can just depend on the full screen nature.
And I can just add my 2 cents of the way that I've used OpenSpace with my existing software is OpenSpace can render out in full dome and 360. So I did a sequence in OpenSpace, rendered it out, and then just used that video in my existing software. So it was pretty seamless that way. And super powerful and super amazing. And I always get jaws to drop when I play that clip.
Yeah, you can. You could use OpenSpace on your laptop to create a video that you render in fisheye and then show that in your dome through your existing video playing software. So I just was going to quickly, not to belabor the point about the planets and browsing and the layers, but I did just want to quickly show the moon. And again, I'll give us a full view here. Just to show that it works in a similar way, just like our Earth. And so you'll see that all our planets are kind of organized like that. But in this case, we have our built-in layers, but also in addition, instead of getting it from NASA Worldview or NOAA Science on a Sphere, we can get layers from NASA Treks. So Moon Trek, Mars Trek, Mercury Trek, and we'll be potentially adding others in the future. And so there's over 750 layers for the moon that are available from NASA Trek that you can add. Here I just have added one as an example, the Kaguya surface gravity colorized. And their server is a little bit slower than the NASA server, so it does take a sec. But now we're looking at the colorized surface gravity of the moon and which parts of the moon have more gravity than others. Again, I'm not actually too sure about when you'd want to use this data set, but the point is they have the data sets that are available on NASA Treks that presumably were gathered for different science reasons and made available. So this story could be talked about when we're talking about landers and commercial landers. They need to know if there's different gravity anomalies on the moon than there is like on Earth and stuff. And so they got to worry about how their lander is going to work and stuff.
I think this one might look really good with a color mode.
Oh,
The color.
yeah, like with the Kaguya over it pulling the color.
Yeah. And I think the other way around, if you turn on the Kaguya surface gravity with a color blending. Oh, never mind.
Yeah. I got you though. How about this? So one of the advanced features that we have is the ability to like reorder the layers and to combine them and have their blending options, mess with their blending options. So in this case, I was able to get the visual image quality of the Kaguya image layer, which has like really nice 10 meter per pixel resolution of the moon, and then add the surface gravity, in with it, which normally when we saw the surface gravity, it was just looking all plain like this, but when we blend it in with the layer, it looks really cool. Now, I was planning on just showing some really cool, nice high-rise layers on Mars and show how easy those stream in and stuff. But maybe I might pause here and see if there's any other questions that have come up or are unrelated to something I show, or maybe about a different feature capability. I see Rosemary's raising her hand.
Yeah, so could you say something about how you're navigating
Oh,
keyboard
yeah.
controls? Are you using a gamepad or
Yeah.
what?
Sure. And actually, let me just give me 2 seconds. Well, okay, no, I actually have a program that can show what I'm doing and stuff. But I think really the key to what I've been doing a lot is I've been using my mouse, left and right button. And then on the keyboard, I have just been using the control key, the F, and the shift F. And so the F and the shift F are our keys for what we call the friction. So F for friction. And I use those a lot when I'm flying to make it smooth. So here, basically I press F and then you notice rotation in the corner changes from green to red. And so now it spins by itself. I'm sure the other softwares have similar features, just maybe a different keyboard. Then same thing could apply for the zooming. So now I'm going to hit Shift F and zoom has gone red. And now I can zoom in and it's zooming in with, well, my hands are free. And then I'm kind of like dragging when I want to get a little faster. And then finally, I'm using the control key and dragging to now pan and tilt the camera. And that's how I get myself my nice like horizon view as I'm landing. Now this one also has the roll, just like the zoom and the rotation. I could actually turn that one red and then it will spin around hands-free. And that's how you really can get a really cool floating in space feeling, but it's like the hardest of all the ones to use. And I often tell people, be careful when you're using that. You might start spinning around where you don't realize it. But basically, if I just turn those back for a second, zoom back out and focus on the moon, when I use the control key and drag, that's the way that we move things off center. So here, like I can move it off center here and then rotate around it and it still stays off center. And so what people don't realize about that a lot of times is that's also how I land, right? Is that I'm using the control key as I'm landing. If I did it beforehand, what would it mean? That I move the moon off center underneath the camera and then just zoom down, and that's a landing on the moon. But really, that's not as nice as I'm going down and as I'm landing and as I'm getting closer. Now I'm holding my control and I'm kind of dragging up to pan it along with the altitude so I can get that nice landing view. And then we also do have the middle mouse button that can spin it. And so we do work with a game controller. You can use Xbox 360, PlayStation 4, custom game controllers. We support this Space Mouse 3D thing that a lot of people like. It's a small little black handheld joystick. I've used it with a old flight control joystick. So we do support a number of ways. But then, as Jeff was mentioning, maybe sometimes either you don't have the hands free to fly there yourself, or you want to be able to talk, or maybe you're just not as good as the flying. And so we do have some built-in features and capabilities, such as right here, if I just want to fly to Earth, I can click on the airplane here. And now that's it. All I did was click on the airplane and it's flying me to Earth. And then I could be talking, or I could be showing something else in the meantime. And it just got me to Earth automatically. And then we've recently added a feature like such as, you know, if I want to go back to the moon, I could fly there, but I could also just jump to just fade right to it. Right. I heard there was a question about the fisheye, and then also we talked about rendering and fisheye and stuff, and I thought maybe for a second I would just show real quick how simple and easy that was in OpenSpace. Basically, I'm going to switch over to showing my whole screen now. And I'm going to quit OpenSpace. Here's that data set catalog of science on a sphere. Are you guys seeing my screen? Hopefully.
Yes.
Okay. And so basically what I was showing before was our normal flat screen setup, and I just had hit start. But if I wanted to show in a fisheye, I could just pick single fisheye and then hit start. And now I'm as soon as it starts up, I'll be running in fisheye. There we go. And so this is one of the really powerful features and great things about OpenSpace is their different like display capabilities and outputs. And as Alex was explaining, it allows us to work in all sorts of different theaters and stuff. But it also allows you to like easily make a fisheye video on your computer, or just run it like you want to connect a laptop to your projector. You have a fisheye projector and you want to like be able to run OpenSpace in your dome. You can pick our second option that says single fisheye GUI, and that will give you two windows. One for your laptop monitor for your menus, and one for your fisheye projector that you can just drag right over to your projector. So there's not even like, you can just, if you have the projector plugged in the laptop, you can just drag that right over to the second monitor. And then you're using your controls over here. And so I just thought, since it's pretty easy to do and pretty powerful, I thought that would be
particularly since you can render out, and Jeff was mentioning that, one thing to point out here is that the resolution at which you create screenshots is not limited by the resolution of the monitor. So even with your laptop, or with the laptop mic, I could now generate 8K or 16K or 30K fisheye screenshots and just render them out. It'll take forever to render, but you can do that by just recording a flight path ahead of time and then rendering it out.
And it's like not even that forever. It's forever in real-time standards, but
yeah, for us, I mean, forever is like a frame a second or so.
Yeah, like I rendered a 4K fisheye video that was 5 minutes, and it only took 10 minutes to render it, or 12 minutes or so. It wasn't like really forever. And then this case is where it's outputting in 360 or equirectangular. So this is like, there's some places that want to bring in and capture with this method, or this is how you could also output for YouTube 360 or for some spherical versions. And so I guess I thought it was worth showing that. I would now maybe even, if I can get Zoom back up, I might, okay, yeah, Rosemary, go ahead.
So somebody had a question about whether you were going to have some internet access capability for the New York event. And I'm also curious, if not, do you plan a workshop that would be for people to participate remotely?
Great question. I I don't know that we have addressed that. Megan, if you have any thoughts or comments, feel free. Otherwise, you don't have to.
We aren't currently planning a virtual option. This is our first meeting at New York at AMNH. So we're just going to see, we'll send out an RSVP shortly. We just set the dates. This is the first group to know about the dates. So we're still working out a lot of the planning, but right now, no virtual option as of now. We are, however, planning some OpenSpace 101 sessions that will promote on our website in the months to come. But that would cover probably just like kind of the stuff Micah is going over now, more in depth, the navigation. We do have a lot of resources on our documentation page that I've been dropping links to in the chat. So if you're wanting a place to get started, I definitely start there.
Thank you.
Okay. Any other items? I could just show one or two more things, but I know we're hitting at the time where if some people got to go, they can. Otherwise, we could take some more questions.
Yeah, so I'll just pause here to say if anybody does need to leave, it's 1 hour in. We're going to continue for a while as long as there's interesting questions going on or Micah has another demonstration, but you're welcome to leave if you need to. And if you haven't signed in, please do so in the chat, just your name and where you're from.
Yes, Alan has a question. Okay.
Yeah, go for it. Shoot.
I remember this was like kind of 20 years ago that I had an undergraduate student program something that would draw data from the CO2 monitoring stations around the world. And that was kind of a difficult task at the time. And I see that what what you guys can do makes that look like lower than child's play. But is there CO2 monitoring that's available as data sets?
Oh yeah. Yeah. And I mean, I guess I would just add that like it only seems like child play because we're building on the, what the shoulders of others, so to speak, right? So the, our globe browsing uses this amazing GDAL library and provides fantastic data sets from the worldview. So it's not, I mean, OpenSpace is amazing, but I just want to say it's not like we made this all happen by ourselves. And so I'll actually switch back to this main view here. So here is
And
the.
And 20 years is like 100 years in human years as well.
Yeah. So this is the NASA Worldview catalog. And I just showed the sea surface temperature and the chlorophyll, but there is, if I hit add layers, I think there's over 1,000. And you were looking for CO2, right?
Well, CO2, actually what we got was CO2 concentration. But
yeah. So, I could search like carbon dioxide measurements. So they have like 6 carbon dioxide measurement layers available. And so there's like a monthly toposphere one, total column average, difference from global mean.
Yeah, I'll jump in and tell you that if I were looking at a carbon dioxide layer for my dome, I wouldn't look at the worldview, I'd look at eyes, eyes.nasa.gov. They have a more public friendly view because that's the raw data. Worldview has the raw data, right, for researchers basically. But if you want something to visualize for an audience, I would go to NASA Eyes.
but if you
and
want to
grab
go
that
and
layer.
if you want to go and click on a particular, like your home, and find out where that, how that CO2 is changing, to get the actual data, you would need, which would you need?
You can do that in eyes, but you can't. What you can get from eyes is you can get the image layer. They have like if you go to Eyes on Earth and just go to the carbon dioxide at the bottom. So that's where you can like actually click on a place and it should tell you the numbers.
That's fantastic.
But it won't show, the number won't show up on your dome. You can just grab that image layer basically.
So Jeff, how do you grab an image layer? NASA eyes, when I think of it, I just think of flat screen and not
Yeah,
necessarily
it's complicated.
projection.
I can show you, but I'm not
Okay,
allowed. I'm not supposed to, I guess.
Oh yeah, that's right. Thank you. You remind me, I'm not supposed to. Yes.
I'm not supposed to
Okay.
anymore, I think. But
Okay,
if I still worked in NASA, I would say just ask me and I would get it for you. But
You have to quote unquote borrow it from their website.
okay. Anyway, sorry for the distraction. So I guess what I'm saying is there's no connection between OpenSpace and NASA eyes directly. Is that correct?
Basically, we have a like a personal connection with them. And then when applicable and when we find something like that they have and we want to include it in OpenSpace, we either get the files from them or we email them and say, hey, we want to add this too. Or sometimes they might come to us and say, like, oh, could you make a video? But there isn't like a direct, like automatic tie-in between the stuff, if that makes a bit of sense.
Hey, Micah, when you were coming back from that exoplanet, I actually had two questions. One, the actual system of the exoplanet didn't have, those were not actual times of the orbits. In other words, it wasn't showing the actual positions of those planets in their orbits, was it?
So I guess I would like kind of give a caveat, or I would like say no, it's not giving like I mean actually it might be. We have
Yeah,
the rotation rate and
the
the values are coming from the exoplanet archive, and so there's like a epoch to the data, right? So
So maybe they are.
could be
yeah,
right.
there's particularly for the ones that are transiting exoplanets, we know pretty well where they were when they were transiting. So
Yeah.
if you go back to the time at which the discovery was made, then they're in their correct position. But you can see here this little fuzzy thing around the orbits. Those are the uncertainties of the semi-major axis. And because there's uncertainty in the semi-major axis, there's some propagation uncertainty of the position of the planet over time. So yes, if you're at the epoch, then it's correct, or it should be correct for the transiting exoplanets. But the further away you get, the more of an error you're accumulating.
Okay, and another question was when you were flying back to Earth, do you happen to have a speedometer that tells what warp speed you're going?
You know, we don't, but we have wanted that and we've thought about it and talked about it because we're often traveling faster than the speed of light, right? And
Yeah.
you want to tell people that and show, like.
I think I added actually one, Micah,
Oh yeah, maybe you did.
in the
Yeah.
dashboard assets.
Oh, maybe.
It's not in the default, you have to drag it in, but there's a
Okay, so
velocity asset that will tell you the speed of the camera.
I'm gonna share my screen so we could see, you guys can see me doing that just because why not? So basically, we have a lot of files and things that are included in OpenSpace that are not like there by default, but are available in our files. And then you can just kind of drag them in. And so in this case, it dragged in the velocity. So camera velocity. Here we go. Light hours, light days, light months, parsecs per second. So we need a warp speed option, but it's so slow to get moving at the speed of light. It's like, oh God. Here we go. Like yeah, I don't even know what is the speed of light. It's like it's so slow. One, you know. So yeah, we've got this, and then we just need like for for our for the date and stuff, you can have like a format and choose some information around the units. So for the velocity one, we can give an option of picking warp speed. Be pretty fun. I'll just show quickly like jump us to the moon since we're on the moon. I'll show quickly another example of the that dragging and dropping stuff. So here, let's say we were like looking at this crater here on the moon, and it was like, well, how big is that crater? So now I'm going to go to educational scale, and I can pick any one of these things. Like, I guess since we're talking PPA, I'll go Golden Gate Bridge. So I'm dragging that one in. And now since I dragged it in, I have this like extra button that says scale objects, drop Golden Gate Bridge under camera. And now it adds the Golden Gate Bridge onto the moon at the crater there. So you can get an idea of how big is that crater. This one happened to be like almost exactly the size of the bridge. That was really a coincidence. Usually it's not that perfectly sized. And then you could like, oh, well, let's go to another crater and see, this one's a lot smaller, right? So this one, if I drop it down the bridge, should like span over it. Yeah, there we go. And so the one caveat about the dragging and dropping is like if it contains like a big file and you've never used it before, it's gonna like have to download the file first, and so it could take some time if it's a big file. If it's a really small file, it'll just do it. Cool. So that's like the drag and drop is just a feature we added like maybe 2 versions ago, and it's pretty handy and pretty nice. It also does have some caveats around when you are in a multi-channel environment, like a 6 projector system, compared to just using it on one computer with a fisheye, or just on one computer flat. But it still does work. You just have to know about when and how you can drag and drop it.
When you drag and drop, does that still show up on the console as a command? Because that's one of the things I love about OpenSpace is that it shows you everything it's doing.
Yeah, great question, Jeff. So here I'm going to bring back to the web here, and I'm going to go to our OpenSpace folder. I'm going to go to logs and go to script log. And basically, every single thing I've ever done as I've launched here, well, since every time you relaunch OpenSpace, shows up in this script log, and it shows up as like a command, and those commands can be reused and like various different places, but basically everything you do gets a command and you can find it. So when I drag and dropped, these were the codes that ran, and so here's that command. You have the OpenSpace asset.add c:/do. For example, here I'll turn off the shading of the moon, and then I can reload my web page and see that very last item is moon perform shading false. And so anytime you do something, I could turn on the moon labels here. And now that says labels enabled true, and then turn them off. Labels enabled false. And so, yeah, everything you do, including dragging and dropping, is if you're interacting with OpenSpace other than moving the camera with your mouse, it's showing up in this command thing so that you could go and investigate it if you want to. Of course, you could just never look at that file ever in your whole life and you'd be fine.
And I used to know how to do it. How do you get like camera positions and waypoints for flying?
Yeah, so basically, like there's kind of 2 ways, I guess. Like, well, there's 3, I don't know. Like one that I often just use, but it's only for teleporting, not for flying, is the quick and easy way is to use our session recording. So this is like Apollo 15 landing site. So I could just say like A15 and hit record and stop recording. And that's kind of like a quick and dirty way. Then, wherever I am in the whole universe, I can just like pick A15 from my list here. I've got a lot of things and hit play and bam, I'm there. But if you wanted to get it so that you could fly to it or something like you were mentioning, then I have this like command, OpenSpace navigation, get navigation state, and I could either print that out with OpenSpace.print debug, and then I'm going to see that it printed out that navigation state there, or I could say like OpenSpace navigation save navigation state. And then it's like saving it to a file on my computer, like right here. And then I could even like, later have that like be loaded, I believe. I think it can do load navigation state. Or then you could do fly to navigation state. So basically, you might say, well, how would I know how to do any of that stuff? If you were trying to do some of the scripting and being able to get to the scripting, we have our OpenSpace documentation website has all of the details about our scripting API. And in this case, the navigation, it has all of the different functions available for the navigation and describing what they do. So here I was using get navigation state, or I was using save navigation state, and tells you it saves it to a file. And then I used load navigation state, and it says sets the camera's position by loading to a file. But then you also have path navigation and maybe fly to navigation state. Create a path with the navigation state, or jump to navigation state, fade to black and jump to it. So
And I should ask, have you tested how well like ChatGPT programs OpenSpace buttons?
Actually, in the past it
I
was
haven't,
not
but Alex
great.
did a little bit, right?
Yeah, in the past it hasn't, because our documentation was only locally. But with version 20, we've started to putting this documentation on our webpage, and at least ChatGPT has since parsed our documentation. So I have successfully asked it to generate actions for me. And I mean, it's generative AI, it's going to make errors, but the errors were like something should have been capitalized, but it didn't capitalize it. But it did generate me a script that was hiding Earth and fading up the moon at the same time.
Wow, it found our Python API now.
Yep.
So
we have a Python API as well.
And so it found it in Python, and it's gonna make the buttons and stuff. Wow, look at what it did, Alex. It used such a weird way to do it.
I know.
I guess that would work though, right? That's crazy.
Yeah.
There you go. Now it's going to use the path navigation to fly to Mars. So yeah, it can do it. It can do it. You might have to work with it a little bit. And then I can say like, can you give me the code in Lua instead of Python? Right? Or I could probably say, ask it to do it using the JavaScript API.
Yep.
As Alex was saying, as we get our documentation online better, it does a good job.
Rosemary has a question as well.
Yeah. Okay. Shoot.
So maybe this is a request for a kind of short, simple answer. I know you may have answered it when you were answering Jeff's question, but I'm used to, in a planetarium program, flying with respect to some object at all times. And you mentioned waypoints. So can you set some kind of 3D waypoints and then set your own trajectory that way?
Yeah. So
Okay.
OpenSpace also works the same, that you're always tied into something. So right now I'm tied into the Earth, or I was tied into the Moon, or I was tied into the ISS. So, for example, like those. If you want to go to a place on Earth, like Paris, I could actually add a waypoint for that. And then now I have Paris, and now I'm locked into Paris. But then if you did want to like make that 3D point like somewhere in space or something like that, then you could use our like bookmark system. So in this case, I'll just drag in like basically we have a CSV file that represents the bookmarks, and then you can like edit the CSV file to add in your own bookmarks. And then they become places you can go to. So here I've just added some stars, right? So I don't have Betelgeuse like someone asked, but if we wanted to see the view from Aldebaran, I could pick that. And now that's my 3D waypoint for Aldebaran. But it's only there because I added it into my bookmarks file.
So
It would
it's still
also
basically some kind of object that you're,
Well, yeah, I technically you might notice Aldebaran doesn't have this checkbox. So you're right. I made an object. The object I made was actually just this sphere, this
Yeah.
like spherical grid, but I had it like turned off so that you don't see it. But yeah, you are tied into an object in that case. But it just the object has its visibility turned off.
I mean, the problem I've had, and sometimes I manage to do it and then I forget what I did, was like with data sets that are only partially covering the sky, like Sloan Digital Sky Survey or something. Sometimes you just want to fly through it so people don't see that fan-like structure and think that
Yes.
space is weird.
Totally. Totally. So you could actually like make yourself a bookmark that is kind of out at the edge, target it, and just fly to that zoom to that bookmark.
Yeah. Okay.
it's also possible. We don't have a user interface for that yet, but this flight path that Micah was showing to fly us down to Earth or fly over to the moon hands-free, that one has a scripting interface as well, where you can actually give it XYZ coordinates of waypoints that you want to visit along the way. That one really depends on where you start the path from. So you would have something, in your case with the Sloan Digital Sky Survey, I would say the first waypoint should be way outside of the solar system. So it doesn't matter where you start the path from, but then you could have the points subsequently going outwards so that you don't see the band structure. Yes. But that would require some Lua scripting under the hood, which you'd only have to do once, that you store it in a button, the same one that like I was using for turning on the global illumination earlier, for example. And then you just have one button, you press it, and then it will always do that flight path.
I have one more question, but I want to wait till the end because I want to make sure other people ask questions.
Okay, here's a really, really simple. Can you just reproduce the old style planetarium functions where it's just you're looking at diurnal motion of the sky from Earth?
Yeah. So basically, here I'll just go down here, and let's say we want to look at it, from this spot in South America, or I could use my location to land exactly where I want. And then I could, there's something I learned recently because I'm not I don't come from that world. I come from the different world. Like I thought that when you're doing that view, you want to be looking out at the horizon. But it turns out that someone was telling me yesterday, no, you don't want to be looking at the horizon. You want to just be looking straight up. So maybe that's what you want to just be looking straight up, right? But then like, here, like we have some of our features here, right? Like you want to see like the ecliptic, right? Or grid, meridian. And then I want to advance time.
Alan, you're muted.
I'm advancing time.
How about, oh, advancing time? That's what I was looking
Yeah.
for. Yeah.
And then I want to see the constellations and, you know, turn on the constellations or just the zodiac ones or.
So that's easy to do, just old style planetarium function.
Yeah. Now I guess I would say that we are like, it's less of how we built OpenSpace, but it like works. And so we have been over the last two versions, like adding new features for that people are asking us for. So like and so we're also taking feedback. So if you did try to do some stuff and there was a feature of this type of show that wasn't working, we would want to know about it and let us know. So like, you know, for example, here we have this like labels, right? Like for the ecliptic here. But like a piece of feedback that we just got was that you know, sometimes you just want to show one axis of the labels of the coordinates and not both axes of the labels. And so could we please add an option to only show one axis of the labels? And so that's something that we'll be adding in a future version as a like a increased functionality for showing what we're calling like night sky or just, you know, a regular star show, regular planetarium show.
So if you were doing this in the fisheye projection, you could see the whole sky as though
Yeah,
you landed on the Earth then.
yeah,
Okay.
yeah. I could
Okay.
quickly show that too as we take any more. But yeah, it's exactly how it would work. So people used to tell us, I can't even do that in OpenSpace. And I said, well, just land on the Earth and look up. And then they'd say, oh, well, okay. Yeah, I guess I can just land on the Earth and look up. But what about this feature and what about that feature? And so in that case, we have been like adding them over time. So now here I am in the fisheye version. And so, you know, if I like turn on the constellations now, I'm seeing a whole sky. And then of course, like, you know, if I wanted to just show one constellation, I could just show like one.
Yeah, Alan, that's the set of buttons that I programmed for you all those years ago.
For OpenSpace?
Yeah, for OpenSpace. I put the buttons in the chat.
Ah, oh, thanks. That reminds me, I got to save the chat. Actually, it's automatically saved for the.
So, you know, we are always adding more stuff. Okay. So the question about Venus is trail, you know, and that's a great question. Here, if we look at our, you know, the trails of our planets in the solar system here, and actually, let me just turn off the ecliptic stuff real quick. You know, someone was asking about Venus and the flower-like spiral. So basically, you know, we have our Venus trail, but I'm gonna drag in another file which has our like other planet trails like from Earth, we call it like Venus trail and then Venus trail from Earth. So now you're gonna see that I drag that in, planets Venus. Now there's this Venus trail from Earth, right? And so now this is that like flower that you were talking about. And you could even like adjust some things to show different amounts of it and stuff. But then I had kind of tried to set it up with this button, since I dragged in the asset that was called Epicycle. I should wind up with these buttons that let me trails. Yeah, so like that let me show them there. So here, now I have them for all the planets. And then, yeah, kind of just the same way with the stars, like if I were to, if I was on Earth and I was looking up at that, I would see it with its retrograde motions and stuff like that. I could,
That's fantastic. Thank you.
yeah, awesome.
Gotta run, but thank you, Micah and
Yeah,
Alex and Megan. Thank you for this. This is great. I'll talk
yeah,
to you guys later. Bye, everybody.
great
Uh,
to see you.
So while Mike is doing that, I want to make sure if somebody has a question that you get a chance to ask.
Micah, we did have a question about adding panoramas to night sky.
Yeah. So, about adding them to night sky. So yeah, we basically you can add a image panorama that would kind of fit in the sky, like they have in some other softwares that would like go in front of the view for you. We were working on them in the last version, but then wound up not including them because we were like trying to buy the images and then couldn't license the images to give away for free. I would hope that maybe we might add that in the next version because because somebody shared with me some that they said I could use for free. And so, but if not, I do have a user that adds their own panoramas for looking at the stars. And so if someone was particularly interested in that, they could ask afterwards and I could get the file and share it with them. Or just ask Ken Murphy on Slack and he could share it with you too, if you're familiar with Ken.
I did have one more question.
Yeah,
At the IPS meeting, it might have been Alex and Paulette Epstein.
yeah.
We're talking about an interface they were making, which might be more user-friendly, but perhaps not as powerful. Could you say
Yes.
something about that?
Yeah, so basically we are like kind of building that right now. It started as a project for like allowing kids to give the planetarium presentations, but then we realized that it would be useful for everybody. And so basically it's an interface that lets you create your own buttons and panels to control OpenSpace and paginate them and stuff. It's similar to a show builder and panels features in other softwares. Basically, the idea is that like if you wanted to create like more of a scripted and easier to use interface, I guess like we're like working on it right now, so I won't actually show it, but what I can show is something that's pretty a little more basic that the whole thing is kind of based off of. A lot of people use OpenSpace right now with a interface that looks like this. We call it our button page. And so they just make these JavaScript buttons, and then you can just use these buttons to control OpenSpace. Like here, I could, focus on the moon if I just press that, or I could like adjust time, make time move using these buttons. And so, but these are still coded using JavaScript and HTML. And so we're basically building an interface that lets you create this type of interface without using HTML and JavaScript coding. So just allowing you to drag and drop and saying new button, fly to moon, new button, turn on moonshell, new button, fade out constellations. And it's actually going to be coming really soon, and we're going to be sharing it with some people to beta test it. It's like really coming along really well. Hopefully it'll be available in our next version, actually.
Okay, thank you very much.
Yeah.
So it's about an hour and a half in. Do we have any more questions? If not, we probably want to kind of wrap it up.
Well, I would thank you all for the questions you gave already. Super happy to be sharing this with you all. And, you know, I would certainly say don't hesitate if you come up with questions later to reach out and get involved. We're making this software for you all and people like you. So
So thank you, Megan, Alex, and Micah. And probably sometime tomorrow, not today, but this weekend, the video will be on our YouTube channel. You can Google PPA officers for the YouTube channel. We'll put links on the website, which is ppadomes.org. And we will also be putting the chat. So all of the links that are in the chat will be recorded there as well.
awesome.
I say
It's
this
great.
that I tend to say this after every seminar, but I think this was one of the best seminars that we've ever had.
Yay.
It was great.
I'll take it. I'll take it.
But you only say that for the really good ones. So
Yeah, right.
Awesome.
yeah. Thank you everybody for coming today, and especially for our speakers. It was really great.
Thank you.
Thanks for having us.